Our universe is a vast and awe-inspiring expanse. It is filled with billions upon billions of galaxies. These galaxies are not randomly scattered throughout space. They are drawn together by gravity into colossal structures called galaxy clusters. Galaxy clusters are the largest known gravitationally bound structures in the cosmos. They are truly giants of the universe, containing hundreds or even thousands of galaxies. These clusters are not just collections of galaxies. They also contain vast amounts of hot gas known as the intra-cluster medium and a mysterious invisible component called dark matter. Galaxy clusters are not static entities. They are dynamic and ever-evolving. Clusters grow over billions of years through a process of mergers and collisions. Smaller groups of galaxies are drawn together by gravity. They collide and merge, forming larger and larger structures. This process of hierarchical assembly leads to the formation of the massive galaxy clusters we observe today. These clusters provide us with a glimpse into the large-scale structure of the universe. They are essential for understanding the evolution of the cosmos. Galaxy clusters are more than just collections of galaxies. They are complex systems composed of three main components: galaxies, the intra-cluster medium, and dark matter. The galaxies themselves, while numerous, only make up a small percentage of the total mass of a cluster. The intra-cluster medium is a diffuse, superheated plasma that permeates the space between galaxies. It is so hot that it emits X-rays, which can be detected by telescopes. This hot gas is enriched with heavy elements. These elements were forged in the cores of stars and then dispersed throughout the cluster by supernova explosions. The most dominant component of galaxy clusters, however, is dark matter. Dark matter is a mysterious substance that does not interact with light. We can only infer its presence through its gravitational effects. It makes up the vast majority of a cluster's mass. Dark matter plays a crucial role in the formation and evolution of these colossal structures. Its gravity pulls together the visible matter, shaping the clusters we observe. The formation of galaxy clusters is an ongoing process that has unfolded over billions of years. It is driven by the relentless force of gravity. In the early universe, matter was distributed more evenly. However, tiny fluctuations in density, amplified by gravity over time, led to the gradual clumping of matter. These clumps grew larger and larger, forming the seeds of galaxy clusters. As these protoclusters grew, their gravitational pull attracted more and more matter from their surroundings. This process, known as accretion, caused the clusters to become increasingly massive and dense. As clusters evolve, they experience a complex interplay of mergers and collisions. Smaller groups and clusters of galaxies, drawn together by their mutual gravity, collide and merge. These events are some of the most energetic in the universe, releasing vast amounts of energy. The mergers and collisions reshape the galaxies within the cluster. They also stir up the intra-cluster medium, heating it to millions of degrees. The formation and evolution of galaxy clusters are ongoing processes. They provide us with a glimpse into the dynamic nature of the universe on the grandest scales. Galaxy clusters are not all the same. They come in a variety of shapes and sizes, reflecting their diverse formation histories. Astronomers broadly classify galaxy clusters into two main types: regular clusters and irregular clusters. Regular clusters are characterized by their smooth, spherical, or elliptical shapes. They tend to be very massive. They often host a central dominant galaxy known as a CD galaxy. These giant elliptical galaxies are thought to form through the mergers of multiple smaller galaxies. Irregular clusters, in contrast, have more irregular and less well-defined shapes. They tend to be less massive than regular clusters. They often show evidence of ongoing mergers and interactions. The Coma cluster, one of the nearest and best-studied galaxy clusters, is an example of a regular cluster. It contains over 1,000 galaxies. The Bullet cluster, on the other hand, is an example of an irregular cluster. It is famous for providing direct evidence for the existence of dark matter. Section 5. Measuring the immeasurable. The mass and size of galaxy clusters. Galaxy clusters are truly colossal structures. They are among the largest gravitationally bound objects in the universe. Measuring their mass and size is a challenging task, but it is crucial for understanding their properties and evolution. Astronomers use various techniques to estimate the mass of galaxy clusters. One method involves studying the motions of galaxies within the cluster. The faster the galaxies move, the stronger the gravitational pull, and hence, the more massive the cluster. Another method utilizes the X-ray emission from the hot intracluster medium. The temperature and distribution of this gas provide clues about the cluster's mass. These methods have revealed that galaxy clusters have typical masses ranging from 10 to the power of 14 to 10 to the power of 15 times the mass of the Sun. In terms of size, galaxy clusters can span hundreds of millions of light-years across. The Coma cluster, for instance, has a diameter of about 20 million light-years. Section 6. Cosmic Celebrities, Notable Galaxy Clusters and Their Secrets. Throughout the observable universe, numerous galaxy clusters stand out as cosmic celebrities. The Coma cluster, about 320 million light-years away, is one such cluster. It is one of the nearest and most massive galaxy clusters known. Another famous cluster is the Bullet cluster, located about 3.7 billion light-years away. It provides compelling evidence for the existence of dark matter. Section 7. Lensing the cosmos, gravitational anomalies in galaxy clusters. Galaxy clusters, due to their immense mass, exert a powerful gravitational pull on their surroundings. This pull is so strong that it can actually bend the fabric of spacetime, a phenomenon predicted by Einstein's theory of general relativity. This bending of spacetime can cause light from distant objects to be distorted and magnified as it passes by a massive cluster, an effect known as gravitational lensing. Galaxy clusters act as giant cosmic lenses, warping and magnifying the light from galaxies located far behind them. This lensing effect can produce spectacular and sometimes bizarre images. Distant galaxies can appear as multiple images, arcs, or even rings around the foreground cluster. Gravitational lensing is a powerful tool for astronomers. It provides a way to study the distribution of mass in galaxy clusters, including the distribution of dark matter. By analyzing the distorted images of background galaxies, astronomers can map the mass distribution within the lensing cluster, revealing the presence of dark matter halos that extend far beyond the visible matter. Section 8. Active galaxies and cooling flows, the energetic side of clusters. Galaxy clusters are not just calm collections of galaxies, they are home to energetic phenomena driven by gravity, gas, and supermassive black holes. Active galactic nuclei, or AGN, are powered by supermassive black holes. Matter falling into these black holes releases energy as jets of particles and radiation. AGN can impact their host galaxies and the intra-cluster medium. Jets from AGN heat the intra-cluster gas, preventing star formation. This AGN feedback regulates galaxy growth and cluster evolution. Section 9. Cosmic Laboratories, Galaxy Clusters, and the Study of Dark Matter. Galaxy clusters serve as invaluable cosmic laboratories for studying dark matter, one of the most profound mysteries in modern astrophysics. Dark matter is a hypothetical form of matter that does not interact with light or other electromagnetic radiation, making it invisible to our telescopes. However, its presence is inferred from its gravitational effects on visible matter, such as stars and galaxies. Galaxy clusters, being the largest gravitationally bound structures in the universe, provide some of the strongest evidence for the existence of dark matter. The motions of galaxies within clusters, the distortion of light from background galaxies due to gravitational lensing, and the X-ray emission from the hot intra-cluster gas all point to the presence of a significant amount of unseen matter, far exceeding the visible matter in these clusters. By studying the distribution and properties of dark matter in galaxy clusters, astronomers hope to gain a better understanding of its nature and its role in the formation and evolution of structure in the universe. Section 10. Windows to the Early Universe. Galaxy clusters as cosmic time machines. Galaxy clusters, due to their vast distances, offer us a glimpse into the distant past. The light from these clusters has traveled for billions of years to reach us. Therefore, when we observe a galaxy cluster, we are seeing it as it was billions of years ago, when the universe was much younger. This ability to look back in time makes galaxy clusters invaluable tools for studying the evolution of galaxies and the universe as a whole. By observing galaxy clusters at different distances, astronomers can trace how the properties of galaxies and clusters have changed over cosmic time. For example, studies of distant galaxy clusters have revealed that the star formation rate in galaxies was much higher in the early universe than it is today. These observations provide valuable insights into the processes that drove galaxy formation and evolution over cosmic history. Section 11. Unraveling the Cosmic Web. The importance of galaxy clusters in cosmology. Galaxy clusters are interconnected, forming a vast cosmic web. This web is a complex network of filaments, sheets, and voids. Studying galaxy clusters helps us understand the universe's large-scale structure. Their distribution reflects dark matter, the cosmic web's scaffolding. Mapping clusters helps test cosmological models and understand galaxy formation.
Like and subscribe to start your journey today.